So in the last lecture, we had seen this code regarding insert at end, and rather we had discussed the way in which we will be doing it. So we said that we have to somehow reach to the last but one node, sorry, the last node, and the new node has to be created. We'll call it as nptr, and the last node we have to call it as, let's say, ptr, and then this ptr arrow next should be pointing to nptr. And to make that happen, this is all. So first we wrote some kind of pseudocode or algorithm. So we said the first thing we want is new node is nptr, then nptr arrow data is some value that we'll put. Nptr arrow next is null because that's the last node. And then I had to go to the last node of the linked list using ptr. So that we just highlighted because we require some code for that. And then finally we will be doing ptr arrow next equal to nptr. So to this highlighted part, basically we know that we discussed that this is how we'll be doing it. Ptr equal to lptr, and while ptr arrow next not equal to null, we'll go to the next node. So it will stop when ptr arrow next equal to null, and then at that point ptr arrow next equal to nptr. The point to note over here, if you have noticed that day, it will also consider the case where the execution does not go inside the while loop. So even then this code has to work. So it works basically. So we saw that even in the case of single node case, this code will work. And another corner case that we had to consider was, what if the given linked list itself is null, rather it is empty? Then in that case the new node created itself becomes the list pointer now. So hoping that there is no further doubt on this aspect, because I had asked you to put up doubts on the chat box. In case even if you have right now, you can do that. But now what we'll do is, otherwise we'll proceed now. Okay. Now let's say that I want to do a different thing, which is now instead of insert at end, I want to do delete at end. Okay. So imagine that basically now this is this new node that I have added, and imagine that I want to delete the node. Okay, or let it be as it is. Okay. So I want to, so over here, when there is a linked list which is given, initially nothing is this ptr nptr I have not decided. What is been given is just lptr, and I have been told that I have to delete the last node. Okay. So somehow I have to go to the last node. So let me think of the algorithm now. So if I go to I know how to stop at the last node, right? Just now we had done it. So maybe I will do the exactly same thing, and I will say that I can stop at the last node through this. Okay, so I know what is the loop which I can use to go to the last node. So maybe I will do this, and I stop over here, and I need to delete the last node. So I will just say that free of ptr, and the last node is deleted. But does that help, or anything else is required? So from diagram, it is much more easier and apparent that what else is might be required. That I go to the last node, I delete the last node, but I require something else over here. What is that something else? So second last node's next pointer has to be set to null, right? So this pointer, it cannot keep on pointing over here because this node has been deleted now, and in which case the previous pointer has to be set to null. Agreed. But now how do I go to the previous node? That is the problem. So there might be multiple ways in which we can do it, and we would choose one of them as perhaps the better way of doing things for a reason. But what ways you can think of to reach to the last but one node? Now I have to reach to the second last node or the last but one node. While I do that, I need to keep track of a lot of problems that I might be creating. So I need to worry about that. So what could be the possible solutions and how I can avoid that? So how do I, essentially the point is, how do I reach to the last but one node is the problem. So let me call this last but one node as the, let's say, prev node. Okay. So I will let me call it instead of PTR, because this I am calling NPTR. This way I call it, let me call this as PTR. So this I want to call the prev node. Okay. So question is, how do I reach to this prev node is the question, and how do I get this prev node? So I know how to stop at the last node. Can I use the similar thing to stop at the last but one node, or something else can be done? So one answer which comes is that the I can stop at PTR arrow next equal to null. Yeah. So because the last but one node will have this property that PTR arrow next equal to null. But what is the downside of this? When I write this, when I write PTR arrow next equal to null, what is the implication? What is the downside? What is it that I need to be careful about? Yeah, single node is present. So when single node is present, PTR arrow next itself is null initially when you start. So then this particular condition will crash your code, right? So you need to worry about, you need to consider the single node case separately perhaps. Okay, what else? So Akshat is telling us some code, how we can do that. Uh, so he says that you can say prev equal to nptr equal to nptr arrow next. Okay, that is another solution. And there is a third solution also. So let me take the third solution. One way in which you could have done, perhaps successfully, is that first you stop at the last node. First you write a loop to stop at the last node. You know how to do that. While ptr arrow next not equal to null, you say ptr equal to ptr arrow next. Ptr will stop at the last node. And now you take another pointer, let's say prev pointer. You start again from the beginning. And now you say that prev arrow next not equal to ptr. Okay. And when prev becomes equal to PTR, then you need to stop. So maybe you have to still catch the condition where it is single node case, in which case the loop will stop immediately, it will not enter. I mean, we have to take care of it. But otherwise, prev next equal to PTR also is the condition of stopping at the last but one node. But then that requires two loops. One loop for PTR to stopping at the last node, and other loop for prev to stop at the last but one node. Okay. So now the question is that how do I avoid writing two loops? So one way is basically that we take two pointers, as Akshat is suggesting that we take two pointers. One is prev, another is the PTR, and these two pointers, prev and PTR, they move in tandem, in together. And PTR is always, one step. I will make sure that PTR is always one step ahead of prev. So PTR is ahead of prev, one step ahead. So when PTR stops, so my condition is still for stopping PTR, which is PTR arrow next not equal to null. So when PTR stops, the prev will also stop at the last but one node. Okay, and then at that point, then I can do the adjustments. I can free PTR, I can do prev arrow next equal to null, etc., etc. So in this case, basically in the delete case, if I need to write the algorithm first, so I will say that what I will do is I will have two pointers. So I have two pointers. I will say PTR and NPTR, and not, let's say, prev and PTR. Let's say. Okay, and we have to consider some, and we'll come to that point again. We have to consider some extra cases. Firstly, the cases that we have to consider is that your linked list, when you are deleting. So what are we doing over here? We are deleting the last node. So we'll have first two pointers, prev and PTR. Before I enter, when I ask to delete the node, just like we did in the earlier case, I need to check if linked list is not empty, which means that if linked list is empty, now of course I cannot delete any node. Now, another thing that has to happen, which is also a special case. Now, in case of deleting the last node, whether it is last or first doesn't matter. Also, is the case which we consider. So check if linked list is not empty. If linked list is empty, then it's an error. If linked list is empty, it's an error. But another case that I need to consider, that it's a single node case, because check if single node linked list. Because just like we saw in the last insert delete at start function, in single node, check if single node case, if it is single node case, then in that case the linked list becomes empty. So this has to be, we had considered this case in the previous situation also, that when insert at start, basically there was single node, but it got considered automatically. If you realize why I'm saying it got considered automatically, look at the code. So the, let's say this is delete at start function. Let's say this is a simpler one. So in which case what we did, we didn't check that condition. Automatically it happened that because LPTR became LPTR arrow next, itself it became null basically, and that's why I don't have to consider this case as a special case. But now what has happened, that got considered automatically, but in this particular case I will have to check this case specifically. It's single node case, because automatically it may not get considered, so I need to worry about it. And then I had to make sure that that prev, let prev reach to last but one node and ptr to the last. So I need to write some kind of loop for this, so that's why I'm highlighting this. And finally I will say that what I require is I had to do, now I have to do the adjustment. So I had to prev arrow next, I will have to do equal to null, and this I can have to do vptr. So this will essentially will delete the last node. And of course, does the list ptr changes anytime when I'm deleting the node? You are deleting the last node, right? I'm not deleting the first node. When first node was being deleted, every time the list ptr was changed. But now in this case, when I'm deleting the last node, the list ptr, lptr does not change, except for the situation when there was a single node case. So in single node case, the list will become empty and the list ptr would change. So which means that again, that condition has to be captured. So having said this, so this is the algorithm now. So maybe I can try writing the code. So first maybe I will write without the status code, and then maybe you can try to write the code by using the status code kind of return type. Okay. So so if I don't want to write by using status code, then in that case I can keep on returning the list ptr, although it is to be written only in one single case, but perhaps I can do that, and I will say that delete at end. And what do I require now in this case? I require the value to be captured just like we did earlier. So I require dptr data pointer, and then I require the list pointer. So which I take this node star in LPT. I can do everything only if the linked list is not empty. Okay. So which means that I have two pointers, so two pointers prev and ptr. So maybe I declare that. I will say struct node star. One is prev and other is ptr. So if I want to write declare these two things separately, it is better that I do star prev star ptr. So because we know that there is this discrepancy in C language declarations, that node star is not a type by itself. I mean, it is a type, but when you have to declare multiple entities, then you have to attach this star with the name of the variable. So maybe I have to do like this. So I have taken these two pointers, and I have to check whether this linked list is empty, which I can do if, so I can do everything only if linked list is not empty. Okay, if it is empty, then I cannot delete a node. So I will check that if lptr is not equal to null, then only everything is possible. Otherwise, I should not be. Uh, Otherwise, maybe I can return back a failure as the status code when I write a function returning status code as the return type. So if LPTR is not null, now perhaps I need to check. But now again, before I move inside, what is the problem? I can directly, there are multiple ways in which I can check whether the linked list has a single node or not. I can directly write the code for reaching to the last nodes. For example, I could do PTR is equal to LPTR. Let's say that I want to reach to the last node through PTR. And I can say while PTR arrow next. This we already know, right? I mean, this is not something special that I'm doing. We already know how to stop at the last node. Well, PTR arrow next not equal to null. I will say PTR equal to PTR arrow next. And when I am saying that, so when I'm doing this, then perhaps I can also do, so PTR is stopping at a last node. So another way I was discussing that perhaps to get my prev at the last but one node, what I could have done basically over here is that I would say prev equal to LPTR, and I will say while prev arrow next not equal to PTR, and then I will say prev equal to prev arrow next. Okay, so this is one way in which I can get PTR as the last node and prev as the last but one node. But then why to use two loops, right? And so firstly, what was the problem by PTR arrow next not equal to null? If someone asks me that question, I will say there is no problem, but then one needs to be very careful when you have this double next coming in or triple next coming in. Tomorrow we will, let's say I want to reach to the third last node. Then in that case, I keep doing PTR arrow next, and there are more chances of creating errors in my code. So normally it's a suggestion that as much as possible keep the arrow next level only at one level basically, and for everything else we can use some intelligent way of writing the code. So one way is basically, of course, this where you actually make prev arrow next not equal to PTR, but then it's one extra loop. So better way, as I think Akshat was suggesting, is that prev is equal to, I will say PTR over here, and then I will say PTR equal to PTR arrow next. So what is happening that if this loop enters, or rather if the execution enters inside this loop, it's always the case that when PTR stops, prev is one step behind. So, and I know that PTR stops as the last node because PTR arrow next not equal to null is being compared. So when PTR stops as the last node, prev is the node before that I know for sure. Now in this case, how do I know that the linked list has a single node? I need to identify the case, right? That linked list has a single node. How do you know that linked list has a single node over here? When prev don't get assigned anywhere, how do I know that something doesn't get assigned anywhere? I think that is difficult to know, right? I mean, how do you take that? So that is difficult to check. What is possible to check perhaps is that we should do prev equal to null before loop. Yeah, that is of course one valid suggestion. So why I am not doing prev equal to null over here, just like I did PTR equal to LPTR. One very, very valid suggestion is that do prev equal to null. Okay, and it's always good to, that's why now you see the importance of initialization. So it's the initialization helps in catching different situations. So prev equal to null will help me after this to check whether prev is still null, means that I have not entered into the while loop, which means that it's a single node case. Or I can check that PTR is still LPTR. Okay, so even if PTR is still LPTR, which means that it's a single node case, because PTR was LPTR and PTR on X is also equal to null, which means that it's a single node case. But now these checks, of course, I can do over here, and those are special cases, because for those cases I need to directly delete that node and set my LPTR to null. But rather than doing it, I mean, we are checking. We are trying to go to the last node, and we are checking whether I did not move inside the loop. Why not basically explicitly check it? So better way, perhaps I think, is that I should explicitly check whether the linked list has single node, and that I can check by saying that if LPTR arrow next is equal to null, if LBTR arrow next is equal to null, then definitely I know that it's a single node case. Okay. So I can write a comment also over here. Single node case, which means that, which also shows that single node case has been handled properly and separately, rather than implicitly trying to find out whether PTR is still LPTR or prev is equal to null. That's an indirect way of saying. It is direct way of saying that I am checking that it's a single node. LPTR arrow next is equal to null. In that case, what I need to do is I can set. I need to perhaps remember. I will say that the node to be deleted is PTR, right? So I will say that PTR is equal to LPTR. Okay, or there are multiple things I can do. I can directly say free of LPTR, which means that a node which is pointed to by LPTR is freed up, and then LPTR has to be set to null. So this is again direct way of setting the stuff. So LPTR is equal to null. So if LPTR, now in this case, this is the single node case, and of course the remaining part has to be secured with else condition. So this else condition I can write over here. Okay. And now perhaps I can do the remaining part. Now in this case I need to set PTR equal to LPTR first, and then I can keep on doing this. So now the code has been separated out in multiple situations. Firstly, we are doing everything when LPTR is not null, when linked list is not empty. When single node case, I am considering separately. When there is a single node, I am freeing that node and I am setting LPTR equal to null. This is being considered separately. And this else part essentially means that the linked list has more than one. And in which case I am doing basically PTR equal to LPTR, while PTR arrow next not equal to null. I'm doing this. Okay. And then when I stop, I can imagine that I will, it has at least two nodes, right? So just imagine that when you have two nodes, what happens? Let's say only two nodes are there. So prev is at this point, PTR also is at this point initially. So prev is not set basically. So PTR is at this point. Well, PTR arrow next not equal to null, PTR will go over here. This is the last node, let's say. So it stops here in the second node, and prev will stop at the first node. That's it. So and then basically, so I get a situation where prev is the previous node and PTR is the next node. Okay, and PTR, in so even in that case, basically what I need to do in all these cases, or I would get a condition where there are more number of nodes. I will get a condition where PTR is this last node and prev is this previous node. So what is it I need to do? I need to delete PTR and I need to set prev arrow next equal to null. So let me do these two things, right? So what I have to do, and that's what we have written, prev arrow next equal to null and free of PTR. So let me do these two things over here. So what I require basically over here is that firstly, I will set, let's say, prev arrow next is equal to null, which means that I have broken the link. Okay. So prev arrow next equal to null. So prev is the previous node, arrow next equal to null. So last node is PTR is separated out now. And then I will do free of PTR. Okay. And with this, I do this. Does LPTR change? LPTR does not change in this case, because the linked list has more than one node. So because linked list has more than one node, LPTR will not change. LPTR will remain as it is. We can see the diagram again. If I have two nodes case, but even if I have two nodes case, this basically this node will be freed up, and this prey, which is nothing but the first node itself, arrow next become null. So two node become one node linked list. Okay, but LPTR even in that case does not change. If there are more number of nodes, anyway LPTR does not change. So basically LPTR changes only when I am in a situation when it was a single node case. Otherwise, LPTR does not change. Okay. So yeah. So now what I need to return back. So now I need to do the bracketing properly. So this else bracket is completed, and this the first if basically linked list not empty, that bracket is not yet completed. So I'm completing that, and finally at the end of the function, I need to write return LPTR, because I know that LPTR changes in one case at least. So I need to write the return statement for return of LPTR. Now, two important points. What did we study in insert at end, and what did we study at delete at end? Okay. Uh, in insert at end, if you ask me, other than we came to know how to write the function, what we studied was how to stop at the last node. Okay, and this is the loop structure that we know can be used to stop at the last node, which will be, this will be required many times over now for us. We may want to stop at the last node, many different reasons we need to stop at the last node. So this is the code template. So we need to understand the structuring of the code. That is more important than what we are doing over here. So this is the last node that we need to stop. And the second one is basically from delete at end. Other than how to know how to delete the node at the end, we studied how to stop at the last but one node, or the previous node. So this is the code template to stop at the last but one node. Okay, which looks basically pretty nice, because firstly it is doing it in a single loop. It doesn't require two loops. And secondly, the prev and PTR are moving in tandem. Once it enters into the while loop, they move step by step. So it is called as they are moving in tandem, or they are moving one after the other. And this is a very nice way of movement of pointers in the linked list. And and it is very clear logically also, it is very clear what is exactly happening over here. So this is the second thing that we studied. Rather, we came to know that this is a good way of moving through the linked list. Okay, when I want to stop at the last node or the last but one node or like that, is a good way of moving through. And we'll see it's not only about stopping at the last node or last but one node. Sometimes we may want to stop in the middle for some different condition, but then I want a previous node also for some reason. Typically in the delete conditions, delete case, it will happen. So I want a previous node also. So this is a very good way of doing things. So this is actually the takeaway from this code. Now what remains is basically to return the status code as failure, but that I am leaving up to you. I mean, you know that when LPTR is equal to null, is not null, status code should be success, and when LPTR is equal to null, status code should be failure. In that case, you return back status code instead of struct node star, but in that case, you need to pass double pointer over here, and then whatever things that we had done earlier to handle such situation, same thing exactly you have to do. So maybe you can take double pointer and just, you still have LPTR and just set it to the star LPPTR. But you don't forget to change star of LPPTR wherever LPTR changes. So that is another way in which this, after writing the status code for this function, we can change this function. Okay, so this I am leaving for you as homework. So now that we have done the insert at end and delete at end, let me stop and let me check whether there are any doubts, any issues, any questions, or anything basically that you want to ask me or you want to point out. So if there is something, I will take it. Otherwise, we'll move forward. So I'm waiting for a couple of minutes. By the way, this prev equal to null, in general also it is a good idea. I mean, although I'm not doing over here, I mean, it's always a good idea to initialize all the pointer variables that you use. So even if I don't have to, but it is, I think I will still say that it's a nice idea to set this prev equal to null, because if something bad thing I'm doing, at least prev equal to null make sure that my code crashes, and so at least I will know that something wrong I'm doing over there. So in general, so although prev equal to null is not being used anywhere, this is a good idea. So let me still do it. It just as a programming practice that your variable should be initialized before you start using them. Okay. So as I said that we have done these two things, and I'll just wait for a minute more just to check whether there are any doubts or any issues which are coming from your end. No question? Okay, doesn't seem to be coming through. So I'm okay with that. So I will assume that you have understood whatever has been taken till now. So essentially what we have done, just to recap, we have done now on linked list, we have done these four important functions: insert at start, delete at start, insert at end, and delete at end. And then now you can imagine that you can perhaps, instead of using insert at start and insert at and delete at start, you can perhaps use insert at end and delete at end also in create list and delete list. It doesn't matter. So it will matter in terms of which nodes get deleted first in the linked list, but otherwise your create list and delete list function can still work. So it's our choice to decide which functions to use, which functionality we require to, or where do I want to insert a node, whether it is at the start or it is at the end, and like that. Okay. So but now we have these four handles: insert at start and end, and delete at start and end, and we know how the code we need to write or we need to create to make this happen. Okay. So so with this, let's move on now. Okay, I don't think there was any question asked. So if there is no question asked, I think, yeah, so we can move on. So let's move on and now go back to our stacks and queues now. Okay, and let's check basically that now what I want to do is I want to implement stack and queue using linked list. So what is the problem with arrays? Just to recap, the problem with arrays is that it becomes full. I mean, the number of entries that you require in array need to be known previously. Okay, so I cannot create dynamically sized arrays, and because of that, when I was using arrays and arrays for stacks and queues implementation, then I required a case to be captured where whether if the array is full, then in that case I need to return back status code as failure, and perhaps that case may happen more often. Just the same problem with arrays versus linked list, that maybe once in a while it so happens that I require 1,000 elements in the stack. Most of the times I require just 100 elements in the stack. So what would happen is, firstly I need to know that I require 1,000 elements at some point in time in every execution of the code, which is difficult because I don't know at what all places my code will be executed. And number two, even if I know that, my data will be vested in array, in the sense that most of the times only 100 elements are used, but I am allocating 1,000 elements. So linked list happens to be a better solution for that problem. And now we will see that how to use linked list to implement stack and queue. Okay. So but now I should not be taking array as the data storage for stack or queue. I need to take linked list as data storage for stack and queue. So let's start with stack. Okay, instead of queue. So queue we will take a little bit later. So first let's start with stack. So when we start with stack, basically, I need to still define the type def for the stack. So what should now the stack structure should contain? So I want to define type def. Essentially, I need to define the type def struct stack tag. Okay, and I need to define this structure, and I need to give the name to this structure as stack. Okay, so if I am using now the linked list, okay, what should this structure should contain? What do I require in the stack by when I use linked list? In when I use array, I require two things. One is the top index, and other was the array itself. Now, before I decide that, in this case, I need to understand where my top is in the case of linked list, and how am I where I'm going to do basically this insert and delete operations. And I think one of you had pointed out earlier when I did linked list that what it was doing. So perhaps there is some thought process actually some of you have that where that should be basically. Someone had pointed out that the linked list I was using for create was something like a stag or something was the comment. So if we go back to that comment, and if you go back to the question that I'm asking right now, that what do I basically, where is my top in the case of linked list, and where should I do the push and pop from? Where is my top basically? And how do I do that? So one way is basically that to say, and I will ask that question again: is there an alternative? But one way which we can immediately see, because we have discussed it, that if I use the top at the start of the linked list and not at the end, okay. Of course, I could use at the end also if you realize that if I as long as I do the both insert and delete operations at the same end, whether it is start or the end of the linked list does not matter. As it is about the end which matters. So as long as both operations are done on the same end, it is still fine. Let's say in case of arrays, if you realize that our array was or stack was growing from left to right, so our stack was going from left to right. So I said that you turn that array 90 degrees anti-clockwise, and you would get a stack basically from bottom to top. Now in this case, I will say that if your insert and delete or push or pop is happening at the start of the array, the start of the linked list, then in that case I will say you turn it 90 degrees clockwise, and you will still see the stack being created from bottom to top. So your top will be at the start. So what matters is basically that this insert and delete has to happen on the same end. That is first. So I require a top, and top is nothing but LPTR. So if I take top, which is basically, I can always define node. Node has already been defined, let's say. But if you want to define it again, once again, maybe I need to give type def for item type, and I will call it's nothing but integer. Okay. So, and then I will perhaps define a node which I want to use, struct node. So again, I can define for this node also I can define a type def. I don't know whether I should be doing it right now, but I can do type def. Let me do it, and then over here I will say node tag. And what this node contains, I know what the node contains. It contains item type data, and I will contain struct. I will say it contains struct node tag pointer next. Okay. It is same as, and this I will name as node. So now the change that I have done is I have defined node itself as a type now. Okay. Have you see? Can you see this type def? This structure will be called as node. So node itself is not struct node. Node itself is a struct node tag, and node itself is a type now. Okay. So this small change I have done, and second change I have done is this int data was there. I change it to item type data. So what is the use? The use is that tomorrow if I want a different stack of floats, basically I can just need to change this into float, and everything else remains the same. And then what I need to do is I need to say that I require a top, and I will say that I will say node star. Now I need not struct node star. I can just say node star basically, and I can say top. Do I require linked list basically? Do I require, just like in the case of arrays, I had a top and I had an array. Now I have a top over here. So do I have a separate linked list now? In case of stack declaration by using arrays, you had two fields, right? One was the top field, other was the array field. I'm asking the question that in the linked list declaration now, do I need to have two fields? One is top, which I have just declared, and do I need to have separate LPTR, which stands for the linked list? What do you think? Yeah, no answer. Do I require a separate linked list is the question. I'm contrasting it with the array implementation of stack, where we had a top and we had an array. These two things were separate. Now I have this top pointer. Do I require a linked list now? We can use the old implementation. Okay, what does that mean? Which we just did. I don't understand. I think question is not clear. Question is this, that let's go back to the stack implementation using arrays. Let's go back earlier where it is. I am saying that when I created stack by using arrays, I had these two elements inside the stack structure. One was int top and otherwise item type elements. This elements was an array and top was the index. There are two fields inside. My question is very simple, that in this declaration just now what I have given this top declaration for top. Do I require to have another declaration for the, so top is just an index, right? I mean, it's just a pointer. So do I require another declaration for the actual contents of that stack? Just like I had array over there, do I need to have separate linked list over here? That is the question. So answers that are coming through is that no, we don't require it. Why don't I require it? We can create new nodes and link them. Any other better answer? Yeah, data is stored in the node. So what? Remember, node is like the single element of the array, right? Do you realize that? So node is like a single element in the array. So even in the earlier case array, we are saving at one single location. But now the question is that this there I had a top which was an index which was pointing to the top of the stack. I am saying that just by taking similar implementation, I may require a top and I may require a linked list pointer, LPTR. So shall I do something like, I have, for example, what I mean is, shall I do something like node star top and node star LPTR, where LPTR stands for the linked list which contains all the data, and top is just a pointer which is pointing to the start of the linked list. Do I require that? So this is the question that I was asking. So think over this, and we will discuss this tomorrow in the tomorrow's class. So now, yeah, there is some answers are coming. Vishaka is saying yes, it is required. Gaurav is saying we only need operations and the start of the linked list. So I don't know what he wants to imply with that. So I will keep answering. So it's already 9:56. So rather than me answering this point, let me keep it hanging right now, and let me ask this question tomorrow again. So tomorrow we'll meet at 10 o'clock in the morning. We'll have two classes tomorrow, 10 o'clock and 2 o'clock class. So 10 o'clock class we'll meet in the morning and we'll start discussing from this point onwards. Okay. So also think of how the implementation will go for the stack as well as for the queue. So both things will try to finish tomorrow, and we'll see basically. So we have two classes. Every day we'll finish both stacks and queues, and maybe we should be able to start something on the some other functions of linked list also. So if you do a little bit of thinking, this should be easier. Okay. So that's it basically for now. If you have any comments or suggestions, you can put on the chat box regarding this question that I asked. I will address all those in the beginning. Thank you.